Hello, everybody, and welcome to our webinar. I'm Johannes Simic with Akatech from the German Academy of Science and Engineering. I'll start here in just a few slides here with our survey before we have the full welcome and introduction to the webinar. So join us here via the QR code. We will also post a link to the chat that you can follow up then to go to Slido. Just since we're a public webinar, we'd like to know who's in our audience, what is your main focus regarding EU digital product passports, and then also where are you at in preparing for DPPs. So how prepared do you feel to be compliant for EU battery passports, from a range from not at all prepared, fully prepared, 1 to 5, and the same range also available on the data requirements. It's a separate question, and another separate question on the understanding of the technical system needed for the EU battery passport. So with that results, hopefully a lot of you will join us in this survey. We will also come back to you in this webinar before the Q&A session to report on what you've told us about your status quo. And with that, I will actually already hand over to Thomas Knote, our project lead. Thomas.
So welcome from my side. Thank you so much participating to this webinar. I think based on the first introductions last year, now we will focus today on the achievements and the things you can as well, let me say, try out. And that's really the important part. And on the other hand, we will have as well some insights to the other stakeholders which are mainly involved into the entire DPP system development. Maybe we can switch to the next slide. Yeah. The first one will be Franziska Zibold from DG GROW. She is responsible together with an entire team to make the DPP system and all the regulatory issues up and running so that we can start with the battery pass next year or early next year, but even for the next ones. Then we will come to the insights of the results, including our system as we had developed, and provide a demo for you so that you can as well try out the first results. And then we come to Carolynn. I'm very happy to have her here. I think most of you know her already because she is responsible for the CIRPASS 2 project, which is the one who enables for the industry the DPP systems in different sectors in order to make them happen as pilots, in order to show how this works and where the circumstances. And of course, interoperability testing is here an issue as well. And later on, we come to the Q&A session where you can come with questions and we will answer as much as possible on that side. But now I would like to hand over to Franziska Zibold. But before she will start, I would like to mention to you the great job DG GROW has done for the standardization. May you know I'm responsible or involved into standardization, and the first 6 standards of the Senelec JTC 24 are now going into the formal vote of the national standardization bodies. And the major topic or the major task was done by DG GROW in at least between Christmas and New Year. They performed the entire assessment of the standards in just a couple of days, and this is world record. So I'm quite happy to have Franziska here, and now it's your view where we are with our DPP system and what is going on in next time. Thank you so much.
Thank you very much, Thomas. Hello, my name is Franziska Zibold. I'm working at DG GROW at the European Commission, and I'm now going to try to share my slides. So I hope that's working. Here we are. And I'm just giving you a quick overview. As Thomas already explained, I'm mainly responsible for the introduction of the general digital product passport system. So I'm not a technical expert on batteries. In my team, we are currently working on the infrastructure to onboard the batteries in the registry and to build a general infrastructure for all the DPPs that will then follow with the different product-related acts. I will give you a quick overview of what we understand in the moment as what the digital product passport is, then also the legal framework, the technical framework, and the way forward. The slides are quite detailed. I will not go through all of them, but we can share them also after the webinar with you. Yeah, so we see the digital product passport as a container for all types of information, be this eco-design data, but also any other product-related data. And when we look at the legal framework in the moment, we have the legal basis in the eco-design regulation. So the eco-design regulation determines actually the main features of it. And then based on that regulation, you will have later on delegated acts, for example, for textiles and other products. At the same time, you have standalone legislation, which also refers to the DPP. Most prominent, the battery regulation, which has an amendment that also refers to the registry in the eco-design regulation. So the idea is that the batteries will go into the same registry and are kind of also a category of DPP. At the same time, you have the toy safety regulation that predicts that the declaration of conformity will be provided via the DPP. You have the detergent regulation, packaging and waste packaging regulation, and the construction products regulation that all have taken on provisions concerning the DPP. So we have here a different status quo of these different legal acts. I'm not going to go into detail, but you can already imagine that this leads to a certain challenge because all these acts are also negotiated in Parliament and with the Council, and in the end there are some little amendments. They refer to the DPP provisions, and we have there some issues that in the end the provisions vary a little bit and have all types of different little deviations concerning the DPP. So they should be integrated across a wide range of sectoral legislation, and it should also serve many objectives, but at the same time, we face in the moment a bit the danger that there will be legal fragmentation. So we are also internally thinking on how we can solve this problem. And one of the potential solutions will be to introduce the digital product passport, or to kind of have it in the new legislative framework, which is actually going to be in the moment, it's in development in the moment. There's a consultation ongoing, and it's part of this new European Product Act. And there would be the possibility to have then more general harmonized rules for all the different products that determine the features of the DPP, and with that it would not be any more necessary to cross-refer each time in each legislative act and recite the provisions on the DPP. This is a bit what we are working in the moment on, besides the general implementation of our system. And this is also a bit what I want to share with you today. So this is what we are discussing in the moment. Also the possibility to reuse the DPP for regulatory compliance, also digitalizing more product data, and also facilitating the work of market surveillance authorities. And we see many benefits of the DPP. On the one hand, for consumers, more informed decision-making, also all the paper-based instructions and other papers would fall away. The packaging would be easier to understand. For businesses, we see that the supply chain management is facilitated. Any kind of reporting processes can be done with the same kind of machine-readable data. And also there will be new business models that are facilitated with this available data to provide, for example, to a recycler real data, what actually is on the market, what he has available and what he can do with this type of content. And it will also help the counterfeiting work and to avoid the counterfeits or to reduce the amount of counterfeit products in the internal market. For the authorities, there is also benefits. The verification of compliance is much faster. It is easier to deal with one product because you will have all the data in one place. and non-compliant and unsafe products can be flagged on the long run, potentially even showing up when you scan like the code. There will be some kind of warning that something is not in line, and then these products will be distinguished from the others, and this will also help to have a safer purchase for consumers. So when we now look at the technical framework, so moving back from all this thinking ahead a bit what has happened, as Thomas said, we developed this, as we asked Sensenelec to develop the technical standards, and I can give back my appreciation of the work of the technical committee and all the technical experts that have engaged in this committee with a lot of time and in fast speed to develop these standards. I think this whole development is now considered as an example case of standardization. So it's quite impressive how fast this all has moved ahead. 6 of the standards are nearly finished. We hope to publish them in the second trimester of this year, the latest. And and we have also a lot of global interest in the European standardization, and also from other countries coming to the Commission wanting to create interoperability beyond the internal market. Here again, the standards. So what's the way forward? So for you, it's probably quite relevant to know how the development is ongoing with the registry, because that will be the first step for the batteries. So we are finalizing the implementing act in the moment for the registry. We will have consultations in the Eco Design Forum. Here are the dates also for those. I will share this presentation after the webinar, and the finalization of the act should be in the end of June, early July. And this will be also when the registry will go live in its first version. So we are working in the moment hand in hand with the technical developers to also have the requirements in line with the registry then being developed and being ready to onboard the batteries. The first version will be a very basic version, but we will already take on board all the options to build a very kind of flexible and practical system for the long run that can then onboard all types of products. So the milestones are actually that we are planning to launch the registry in July 2026, and then in February 2027, the first products will be on the market, which will be the big batteries. Here are the other priority products set out in the work program. This work program can also be consulted online. The next products will be iron and steel, as well as textiles. So the Commission intends also to help stakeholders with technical guidance documentation, and also potentially open source tools to help companies to create DPPs and validate their structure. Exactly. Here is a bit of an overview, and that's it. You can contact us via this email address here. This is very helpful because with that we can attribute you immediately to the right contact person, and I will still remain in the webinar for questions later on. Thank you.
So my name is Patrick Gehring, researcher at Fraunhofer IPK, and I will give you a brief introduction to the BatteryPass-Ready project. Next slide, please. BatteryPass-Ready is a pre-competitive project designed to support the industry in implementing the EU battery passport. And our main deliverables are a test system on one side and a practical guidance so that companies can validate their solutions before the regulation fully applies. The project is co-funded by the German Federal Ministry for Economic Affairs and Energy and runs for 2 years from April 2025 to March 2027. It builds directly on the previous BatteryPass project, if you're familiar with that, and brings together a consortium of research institutes and industry partners consisting of Fraunhofer IPK, Arcatec, GFEC, and TU Berlin, with support from our associated partners representing the industries. Next slide, please. To understand why we need such a test environment, it's important to look at the overall battery passport ecosystem. This diagram shows the battery over its entire life cycle, like from mining and refining to cell, module, and pack production, first use, potential second life, and finally dismantling and recycling. For our project, our practical focus starts at the moment when a battery is placed on the market and the battery passport is published for the first time. So the upstream value chain and processes before passport issuance are out of scope for the test environment. Along this journey, battery passports are created, updated over time, for instance, due to changes in dynamic data or after minor repairs. New passports may be created, for example, when batteries are repurposed or remanufactured, and eventually cease to exist. Many actors interact with the battery passport. Economic operators need to give access to the internal systems. We have the EU registry as a central service, third-party services such as backup providers, and of course the oversight by enforcement authorities. And our focus in BatteryPass-Ready is on testing the interaction at an API level between the registry, economic operator systems, and third-party systems, ensuring that functions like creation, registration, reading, updating, deletion of battery passports works in a consistent and compliant way. And this complexity is exactly what our test environment has to reflect. Next slide, please. You can just go through the next. Complexity is not only our only challenge. The timeline is tight. Technical standards in Sense and like JDC24 are expected by mid-2026, as we just heard, while delegated acts that specify many of the data requirements are still in development. Second, the ecosystem is dynamic. System specifications and data requirements are evolving, which means that companies will need frequent validation of their implementation. BatteryPass-Ready responds to these challenges on different levels. We aim to develop a test system to validate data completeness and plausibility, to verify functions and interoperability between systems, and we aim to provide guidance both for policymakers and implementers, and of course describe different options for an operating model for a long-time test system beyond the scope of our project. Slide. To make sure the test environment meets real-world needs, we have involved a broad set of associated partners in an advisory board. What you can see on the slide are the representatives from research organizations, standardization bodies, and industry associations. And their role is to provide feedback on our assumptions, contribute to sector-specific perspectives, and in general help align the project with ongoing policy and standardization work. And this external input for us is essential to ensure that our test system is not just technically sound, but also like practically useful and aligned with regulatory expectations. Next slide. Beyond the core consortium and the advisory board, BatteryPass-Ready is backed by more than 100 supporting partners by now. These supporting partners include companies and organizations from across the battery value chain and the digital product passport ecosystem. And their interest shows that the need for practical testing and guidance is very high. We will continue to involve them through workshops, consultations, and pilot activities so that the test environment reflects a wide range of business needs and technical setups. Next slide. Let's have a look at our timeline from 2025 to 2027. Our milestone follows the following logic. Like first, we design and define the test environment, and then implementing it so it's functionally applicable, and finally optimizing it, defining an operator model, and like preparing the rollout. As of today, we have gathered system requirements from stakeholders, updated the battery passport data attribute list, which currently goes under a public consultation, and developed our first prototype of the test environment, which you see in a minute. Slide. To design our architecture, we have to work with several regulatory assumptions. The final JDC24 standards are not yet out. Delegated and implementing acts are still to follow, and some details are still unclear and under discussion. Just to give you some examples, what kind of questions we're dealing with. For example, we know that battery passports must be registered in EU registry according to Article 77 of the battery regulation. What is still unclear, though, is which specific identifiers will need to be provided to the registry. There's some difference in the JTC24 API specifications and the regulatory requirements of the battery regulation. Second, battery passwords must remain available even if the responsible economic operator ceases to exist, as we know by Article 78 of the battery regulation. This implies that some sort of backup or continuation service needs to be in place. What we just don't know yet is whether this needs to be done by a third-party backup service provider or not. And sometimes those small little details can make a big difference, especially when you look into testing. So what we are trying to do is building our test architecture to accommodate those assumptions and to stay flexible as much as possible, so we can adapt as the delegated acts and technical details are finalized. And with that, I will hand over to my colleague Elena. Oh, Johannes, sorry.
Yet Elena is coming up shortly. I will talk about battery passport data before. We've just need to manage a few more things here. All right. We've been dealing with the battery passport data obviously for quite some time, before in the BatteryPass project as well. Our task here in this project is now twofold. On the left-hand side, we want to support compliant implementation by looking at completeness and the content of the data. That means that we need to track the ongoing processes and apply those to the existing data attributes. We have our data attribute list, which I will go into detail about in a second, and update it with the current procedures in the delegated acts, in other omnibus legislations, and so on. Also the JTC24 drafts. So that is what we need to monitor and then update our data model with it. And then on the right-hand side, we have topic of plausibility. So that means, first of all, we need to define the general criteria, like which plausibility tests do we want to do. We will focus on formatting, we will focus on threshold tests, also maybe order of magnitude checks. We will not go into the close details of methodology, for example, because that goes far beyond the scope of this project to really look at carbon footprint, for example. And so once we have those general criteria, we will apply them to our data attributes again and have those plausibility testing rules on top of the data attribute list and data model. Today, I will only expand in detail about the left-hand side because that's what we started to work on. So that's the data attribute lists. Many of you may know the DIN DKE spec 99100 and the previous BatteryPass project, where we developed a data attribute list and this specification, wrote up what data in the BatteryPass needs to be and how you can understand it. So as an overview, I will not go into each detail here, obviously, but the headlines, we will have the identifiers and product information, labels and conformity information, the carbon footprint of the battery, as well as the supply chain due diligence report about the supply chain of the battery. Then again, the materials and composition, circularity and resource efficiency information that will allow to handle the battery more efficiently and safely. Also for the R strategies in the context of circular economy, so that you have manuals available how to actually deal with the battery in the battery passport. And last but not least, the performance and durability data, where we have a lot of information about the technical make of the battery, but also dynamic data. And that's specific also pretty much to the performance and durability side of the data. We will also have remaining capacity or a measure of the state of health, like the SOCE for EV batteries, and that will need to be updated during the life of the battery. That was what we started with. But as I already laid out before, we have ongoing legislation and ongoing standardization that we need to consider. And there I want to give just a quick update and overview what we consider as relevant and for what we consider as relevant. So here, from the legislation point of view, obviously the battery regulation has a couple of data attributes in not data attributes, sorry, delegated acts in its articles. So we have ongoing delegated acts on carbon footprint and the labeling requirements, where the labeling requirements actually touch upon a couple of information aspects, like also hazardous chemicals, like the capacity of the battery, manufacturing place, and so on. I won't go into all of the 10 things that are in this list, but certainly something to watch here. Recycled content will also be addressed in a delegated act that is planned for the Q3 26 this year. So, and data access obviously is an important aspect where a preparatory study is ongoing, as we understand it, and it should be delivered in summer or fall this year, a delegated act to describe which data attributes need to be accessible by whom. Then we have the ESPR, obviously the technical system of the battery passport, which is affected by that, but also the data. For example, when we have information on how the registry works or on service providers, there may be some data attributes that we need to add to the list for the battery passport to have it work. And also what is underway is the environmental omnibus, for example, that addresses the hazardous chemicals and its reporting in the battery regulation. So that is something, as I mentioned before, that is also addressed in the labeling requirements. So sometimes it's even in two different pieces of legislation where developments are ongoing for one data attribute. That's an overview on legislation. Standardization also is ongoing with the standardization request M579, which deals with performance and durability. There are work streams ongoing for LMT, industrial, and EV separately, obviously because they need to be addressed in a separate way due to its different application circumstances. So that is still ongoing and might get rather close to the start of the battery passport, as I understand it at this moment. Then the JTC24, already mentioned before, has done a lot of work and great work on technical standards, and there is also a list of DPP information that should be in a product passport in general, and on the identifiers that need to be delivered as well within product passport and also to the registry. I will talk about that shortly in a little more detail, but here the last item under standardization processes, one is, for example, ongoing on the European level for EVs, where a specification is about to be drawn up for battery passport data. So that's an overview here. And just to expand a little bit on the effects of the JTC24 drafts that were available last summer. So we have updated our data attribute list, have given it out for consultation in our supporting partner environment. And here are some examples of what we added based on the JTC24 drafts. For example, here the DPP schema version, DPP status and granularity, and daytime of latest update of the DPP. So that is DPP information that we added to our data attribute list. And then on the right-hand side, the identifiers, which are a piece of work on its own, as I may call it. There's a lot to be defined still, also in separating those and their purpose as well. So that is something that we tried in our data attribute list, and are really happy that we got a lot of feedback from the group of the consultation. So thank you also for that at this point. And that's just a outlook on also what we are going to publish this data attribute list in the coming months. So this will obviously also be available to the open and to the public. So stay tuned for our publication on an updated data attribute list. And that's from my side regarding the data attribute list, and I'll hand over to Elena.
Thank you, Hannes. Hello, my name is Elena Andrushenko. I'm a research associate at the Chair of Quality Science at Technical University of Berlin. In the following part of the presentation, let's focus on the flow that help us translate regulatory requirements, how we can translate regulatory requirements into test procedures that lay the foundation of our test environment. So, please. When developing our test environment, we want to evaluate whether battery passport system actually work as intended. So this means checking two things. First, can the system handle the implementation and functional requirements? And the second, can it ensure seamless data exchange? To achieve this, we follow a structured 5-step procedure. We start by analyzing regulations, deriving functional and non-functional requirements. Second, we describe typical application scenarios that we called user stories. And for each user story, we define concrete test scenarios and failure scenarios. And finally, we implement them in our test environment. Next slide, please. The technical foundation for our work comes from the draft standards that were published in July and August last year. As we can see here, there's a whole family of standards covering everything from data exchange protocols, unique identifiers, to data authentication, reliability, and integrity. However, for the developing test environment, two standards were absolutely critical for us. First is 18222 application programming interfaces that defines or which give us an overview of DPP system functionalities. And next one, 18239. That covers access rights management, information system security, and business confidentiality. These two drafts tell us how the system should work and who can use it. Next slide, please. From these two standards, we can derive what actors exist in DPP ecosystem and whose behavior and interest we should consider. On one side, there are different economic operators who manage battery passports, and on the other hand side, there are service providers who host, maintain the passport system, stores and archive product passport versions. We also have regulatory bodies like European Commission and Mark Surveillance Authority, as well as other actors like recycler on professional repairs. Next slide, please. From standard draft 18222 breaks down system interactions into specific technical functions. To simplify the technical representation, we'll give here an overview using an input-output approach. For example, in the standard, there are such functions as registration and read, and registration used to call this function of registration, the system need specific inputs like, for example, operator ID, facility ID, product ID, and backup ID. And when successfully called, the output is registration ID. Another example is a read function, which shows users' battery passport data based on different parameters. For example, they can retrieve the whole passport, and then users should provide product ID and date, or DPP ID, or they can access only specific data from passport, pointing on them using DPP ID with a collection ID or element ID. Next slide. And for our project, we have defined 12 main user stories, and they represent and cover the entire life cycle of the battery passport. It begins with placing the battery on the market, which corresponds to registration process. Then we have reading data, both public and controlled, updating of the battery passport, search information about the battery passport, deletion, as well as validation, transfers of responsibility, repair and recycle of battery, and finally import and export of batteries. Let's take a closer look to one user story, place the battery on the market. To make user stories testable, first we split them in units that we called models. For this user story, we have 4 models: authorization by registry, registration, authorization by service provider, and backup. However, in some areas, the regulations aren't entirely clear yet, so we define working assumptions that help us to move forward with test development. So here are some examples of our work assumptions for these models. For example, for authorization by registry, we are assuming that the process will be performed using eIDAS. And for registration itself, we assume that input parameters should be economic operator, product ID, facility ID, and backup ID, and the registration ID that users become function as a proof of registration rather than being a data point in the DPP itself. For example, for backup, we also assume that creating a backup copy is mandatory for batteries and happens after successful registration using create API that's also defined by standard drafts. Now, by mapping user stories with roles, we can define the test scenarios. Next slide, please. For example, registering batteries and placing them on the market can be done by economic operator or by service providers acting on behalf of economic operators. By testing these scenarios, we should not only consider a test where everything goes well, but also define failure scenarios where we identify what can go wrong to test the behavior of economic operator system. So we create failure cases. And here are some failure cases that are mapped with modules. For example, at the authorization stage with the registry, the economic operator might successfully authenticate via eIDAS, but the account might lack the necessary permission to register battery passports. So the system should reject this with an error message, and system of economic operator should receive this answer. For example, during the registration, economic operator might attempt to register a battery that's already been registered, so that this request must be blocked and indicated that battery is already in the system. Or, for example, by creating a backup, economic operator can send a broken request to the API, so the system cannot understand and cannot parse the data and should give also an appropriate error message. And next slide, please. And in final step, we implement these test scenarios in our test environment, creating test procedures that companies can use to validate their systems. So now I will hand over to Jonathan, who will demonstrate how everything works in practice. Thank you.
Yeah, thank you very much. I'm Jonathan Fritz from GEFEC. We are in this project responsible for the technical implementation of the test environment and all the requirements you saw so far in the earlier slides. Next slide, please. Overall, the objective of this test environment is already presented in the before. Just now with a more technical standpoint right here. In the end, what we try to do in the next month is enabling each interested party to test their own implementation quite early, already before something comes into force in the next year. So we try to implement and upgrade our own test environment in the next upcoming month with more use cases, so that each interested party is able to already see on what and if they are on a good path right now. So overall, on the one side, we might try to foster continuous collaboration together. On the other side, we try to create a workflow in the test environment, which helps each user to have a, let's say, trusted and easy to understand environment. So it doesn't matter in what way the requirements on the EU side change in the future. This test environment should provide you with a tool which is easy to use even right now, but also in the future, in a way where you can easily test everything. Doesn't matter how much and how drastically potential requirements may change. Next slide, please. Here is a small screenshot which shows to some extent the way how we currently design and intend to have the work process with our test environment. You first have a configuration step. I will get into more detail soon. You then choose certain test cases. Those test cases in the end are what you saw in the slides before. In total, in the end, maybe 13. And if you are able to pass all 16 or 13 tests, you are ready to go, and we can confidently say that you follow all so far desired requirements in the EU regulation. So you choose a test case, you make your configuration step, and then you have to do nothing else than just run the execution, and you will get the results of the test. Overall, the results are designed in a transparent way. You can quickly see in each step of the validation what we tested and if you succeeded in this kind of test. We try to make it as automated as possible. So besides the configuration and the test selection, everything else will be done without manual intervention. And we overall have two different ways how you can later on use this test environment. Right now, with this in early testing, we already try to implement it in a way for you that you can use a test environment to iteratively improve your own implementation. So you see the mistakes you maybe have done, you can see potential ways to fix them, then you choose those kind of improvements, test again, and step by step in an iterative process, you can improve your test and your own implementation of a product passport system until everything is fine and ready to go. Another future use case could, of course, be that you just do everything on your own, and you just then for final test, or when you think you implemented everything correctly, only then use our test environment for final check in the regard to quality assurance to see if everything works smoothly. And with that, I will jump directly into the test environment. The test environment consists of currently two different features, which will be built up in the upcoming months as well. The first one is simple validation of your data. So far, this is still a prototype version in the way that you just have a validation of schemas right here. In this case, the base is a validation of the schema which was provided by the last BatteryPass project. And right here, you can, for example, right now see two example ones. You can also, of course, input your own test example file. And in this case, I just pretend like I inputted invalid battery pass. So if I run the validation right now, you can see later on a visualization of all the errors which occurred. Redly marked are all the categories or data elements where something went wrong on the left side. And on the right side, you can see the error message which occurred, giving you some insights on what you have to fix in the future so that this error doesn't occur again. This is the current feature. This will become, of course, more extended in the future. We will provide test functionalities on the data level, which are not just covered by a simple schema validation, for example, plausibility rules. And of course, there is also the chance to include other schemas in the future. So if right now it's, of course, for batteries, but there is no problem in also including other passports in the future for validation as well. That is the first level of the validation. This is just data related. I now come to the second part of the validation, which is about the whole data passport system. Right now, of course, it's still also suited specifically for batteries, but can also be applied to other passports in the future too. Right here, we have the configuration step. You can first see the three things you have to implement yourself. First, you choose your role. In this case, we just pretend like we are an economic operator which tries to place a battery on the market. Here in the middle, you choose and implement your own API with which you are going to communicate with all other stakeholders in the product passport system. So this is in the end your endpoint, which follows all the regulations which are necessary and are defined in the regulations of the JTC. On the right side, you also implement a test adapter, and we will also provide each interested user best practice for this and the documentation on how to implement it. That is necessary to enable you to use a test environment in a way where we don't access your data. Yeah, in the end, this test environment adapter is, let's say, a middleman. It's some kind of interface which communicates between our test adapter's test environment solution and your own product passport implementation in a way which is not harmful for your system. And to enable that, and to be able that this also works with each implementation of each interested user, this has to be implemented by you as a user as well. But we will, like I said already, provide some good feedback right here and some good manual for you to implement it as quickly and efficiently as possible. So if you have set up everything like we did it right here, in this example for this presentation, we have prepared some interfaces. In this case, one interface which always generates a valid product passport. Let's assume I then want to test something. So I choose right here test case. So far, we have just 3 test cases available. In the future, this will, of course, become more. As you saw in Elena's slides, in total, we have 13 use cases. So in the end, we will have at least 13 test cases right here. And I click on this test case. Then I click on execute. And now the test is running. So we will now see if this implementation of the product passport system is actually following all things which you have to do when creating and placing a battery on the market. You can see some of the requirements right here. You first, of course, have to make a registration with the registry. You have to be able to also provide the data to a backup provider. That's at least what we assume right now. And if you have made the test and if you implemented the API like this right here with the valid product passport generation, which of course is just an example right now, you can see the results right here. What happens is in the end that we test certain steps and see if you did all the requirements based on those steps. For example, right here, we check if your own system was actually able to call the from us emulated registry. If it was successful, you get a positive feedback right here. Then were you able to actually provide the passport to a backup provider? Are you enabling read access to the passport? And also right here, a validation of your passport, and so on and so forth. So these are the steps we test. And if everything works, you can be confident to say that your own implementation of the passport system is able to successfully place a battery on the market. I give you one example what happens if you make a mistake. Let's assume we have implemented an API in the product passport system, which is currently not able to generate valid product passports. And if we execute this step right then, you will see that we have at least one failed step, in this case with the data validation, because yet again, the passport was incorrect. We can also make another example. Let's assume you are currently not able to create an API which actually generates a passport at all. If that happens, you can see another error in this case, or some example, because of course, already right now before, right here, and the read point, we already see a mistake, and therefore the system is not able to make a validation afterwards. So overall, depending on how well you implement your system, you can get feedback on what works already, what does not work, and you can adapt and improve your own implementation accordingly. And with that, we come to the last slide for my part about the rollout of our test environment. So far, we are still developing it together with selected stakeholders, supporting partners, which were ready and willing to already give us right now in this early stage some feedback. And we will proceed with this process for a few more months to finalize some steps and also include some more use cases. And then in June this year, we also intend to roll out this test environment to all interested parties. So from June on, if you're interested, you can manage us. The way how we provide it will also still be made available in the upcoming month. And then you have also the chance to test out this test environment yourself. And with this, I give over to Carolynn and Carolynn, sorry, and I'm ready for other questions after the presentation and the Q&A question. Thank you very much.
Carolynn, we don't hear you if you were about to speak. But now, maybe?
Johannes, can you see my slides?
Yes. Yes, we
Great.
can see them and hear you. Thank you.
So thank you very much to the BatteryPass-Ready team for inviting me to present the CIRPASS 2's take on building interoperability for DPPs and other sectors. So I think you will see that the approach that we're investigating in the context of CIRPASS 2 is very complementary with respect to what has already been presented today. So very briefly, CIRPASS 2 is about wide-scale piloting of DPPs in many different sectors. There are 13 piloting ecosystems within the project. So here a very brief snapshot is given of the different piloting environments. You'll notice there are 6 pilots focusing on products related to textiles, but not only garments. There are 5 pilots looking at electronic or electrotechnical equipment, and there is a pilot focusing on tires, and one is focusing on the construction sector. And the reason there are so many different products being addressed within CIRPASS 2 is that we strongly believe that the diversity of pilots is really key to ensure that what we're building and that the standards for the DPP system are aligned with the current state of the industry and the diverse needs of industry. So we also want to prove that these standards can be applied for different sectors, so they're truly cross-sectoral. And this huge diversity means that the system will be future-proof if it can absorb such diversity. So within CIRPASS 2, we have an additional goal, which is to prove that the DPP can be used beyond regulatory requirements and that it can promote both economic and environmental sustainability. So this was mentioned before by our colleague from the European Commission, and you will notice that amongst the products that are addressed by our pilots, many of them may be the target of coming delegated acts under ESPR. So just some brief note about our pilots. They're all being managed and hosted by a different DPP service provider who uses a different IT solution to provide DPPs. They all have voluntary circular economy business cases. So some are focusing on repair, some are focusing on maintenance, some are focusing on refurbishing or recycling, etc. And all of these business cases are using voluntary data that is attached to the DPP. Okay. All of our pilots use different data modeling approaches. Some use standards, most don't. Okay, so we have to absorb this variety. And it is very likely that in some future, more or less distant future, they will have to convert their use case from a voluntary DPP use case to a both voluntary and mandatory DPP use case. So the challenge we have is to accompany this evolution. Of course, today, currently, none of them are interoperable with each other outside of their existing business ecosystems, and this is what exactly the Senelec JDC 24 standards are here to change. CIRPASS 2 has published a wide variety of recommendations for the implementation of the EU DPP system. You can find this on our website. In December, we published a revision of our user stories. So this is our most recent publication. And taking a figure out of our proposal for a reference architecture, I just took this figure from that report here. So I use this figure here to illustrate how within the project we will build interoperability testing components. And this is what I want to focus on here in this meeting. And the goal here of what I'm presenting is to check that the different CIRPASS 2 pilots will be able to at least meet this minimum level of interoperability. So the first thing we want to focus on is, of course, the EU registry. We have published a open source version of a mock EU registry implementation on the CIRPASS 2 GitHub. It's already available. You can go there directly, download it, test it, throw rocks at it, tell us how horrible it is and how it should be improved. And this is what we want to do here is we want to check that all pilots can consistently register their products in the EU registry. In the future, we also want to explore how the future EU web portal can work so that the DPP data can be searched in a consistent manner. We also want to make sure that all DPPs, whoever is issuing this DPP, can be validated according to a specific reference DPP template, mandatory template, and that the DPP contains the consistent referencing to the mandatory vocabularies that will provide legal authority for conformity of the DPP data. Next, we also want to focus on another aspect, a completely different aspect that was not covered in the previous presentation. So we want to see how the DPP data can be provided to consumers in a visually consistent manner. Okay, so in parallel to the previous task, we have an additional task which consists of building a DPP consumer app. So this is an optional component that could be used in the future by consumers. And we want to make sure that there is a consistent rendering and consumer user experience with DPP data. That's the purpose of this task. And finally, we have a task that aims to check that the DPPs can be consistently registered on e-commerce platforms, because this is a very important methodology by which consumers will have access to DPP data. Just summarizing, summing up, all of these different tasks will be crucial for us to refine our recommendations for the DPP implementation and for identifying remaining gaps in the Sensenelec JDC 24 standards. Thank you very much for your attention.
Very much, Carolynn. Really great insights into what you and all of your colleagues in CIRPASS 2 are doing. Really complex to have all those pilots going on. Have some interoperable. Thank you. We'll also have you obviously on for the Q&A part that is going to start soon. I'm just going to come back on the survey results that we started initially and then go right into the Q&A. Now here we go. As you see, we have a lot of recommended operators, but I already moved further to the preparedness. That's the overall result on the survey. How prepared do you feel at all? This is a nice distribution, quite even, so to speak, but good to see that we have some in our room who feel really very prepared or fully prepared. Others at the other end have a couple of things still to prepare, but a lot of people in the middle of this preparation. Then when we divide it up into data requirements for the EU battery passport, so battery specific, we also see quite the distribution, but a little more already on the quite clear aspect of the battery passport data. When we go back to the technical system for the battery passport, there's more unclarity. So if we compare the previous distribution of data and on the technical system, then there's apparently some more things to be known to really start the battery passport system, which is also, I think, understandable given that the JTC standards are still going to be published in their final state. So I think that's also a little bit reflecting that. So now with that, I would like to go to the question and answer session, and would like to start right away with the question: with all those open points for the battery pass, will the deadline for companies to implement the battery pass still be February 2027? Who in the group wants to reply?
Probably I'm the one from the commission, but as I said,
Yeah.
I'm not the expert on batteries. The only thing I can say is speak up, identify the issues, communicate them to the commission. It's Unit I4, which is responsible for the battery pass, as you probably know. It's also good to read here the questions and issues in the chat. I will also take note of those which I can't answer. And I think it's important to raise these issues either via the industry associations or other member state representations to raise the issues, the concrete issues, providing, for example, also technical details or data why you think it's not possible to do it, not just saying we don't like it or it's not clear or this is not, just say the exact paragraph or the exact content that you have issues with so that we can also know about that. I think that's always super important. Sometimes it's very difficult to know what the real difficulties are, and it also helps a lot to provide numbers. I also wanted to clarify this point on the backup. To my reading and also in liaison with the batteries team, the batteries regulation as such does not require a backup during the lifetime of the battery. So when the battery is hosted by the battery operator, by the company, then it's not necessary to have a backup at the same time. Just necessary to have a backup when the company ceases to exist. This is our reading of that part of the legislation. So it's different from the other TPPs, which under the eco-design regulation require a backup from a third party during the lifetime of the product already.
Okay. That's really, really good addition, and thank you for getting to work to those questions. Really good replies. I heard Thomas, if you wanted to reply to anything of that as well.
Yes, Franziska is right. In the battery regulation, there is no backup service, let me say, requested as mandatory. But as we can see already in the current activities in the Omnibus packages like Omnibus IV and so on, we will have more and more, let me say, alignment between the different regulations. So I guess, Franziska, I'm not quite wrong if we can say, okay, in the future we will have the, let me say, alignment and harmonization between the different regulations as well between ESPR and battery regulation and others regarding the system application like the backup service. Or I'm wrong?
Yes, I agree with you, Thomas, that this may happen, but I think it's also important to, for now, prepare to the essential requirements. So everything that is essentially needed is the first step, and everything else then comes after. So if in the moment it's a minimum requirement to have a backup, for example, to have a contract with a service provider that gives you the backup in case you cease to exist, this would be sufficient for the moment. There is no need to have that during the existence of the company. So in the moment it's fine, but I agree that on the long run there would be potentially some alignment on these requirements across all the products, but this is not yet in the planning. Yeah.
And of course, for such very important data points, means the battery data, I don't see that any economic operator will work without any backup. So at the end, it is an issue how to design your system in order to be able to change easily from your own backup to have an operated backup by a third party. I think that this is maybe a recommendation for the design for the economic operators to create their system in a way that they can outsource this as easy as possible in the future.
Thank you for the addition, Thomas. I already just saw that somebody raised their hand to actually pose a question, so that's obviously also welcome. So feel free to raise a hand. We'll go through the Q&A questions that are rated the highest, nonetheless, at the moment. But feel free to raise your hand to actually pose your question. So the next question that I have in line here is something more battery specific. Also, what happens to the original digital battery passport when the battery is repurposed and remanufactured? Should the battery pass of the original battery be deleted? Should it link to a new battery pass of a repurposed battery? If it should link, how long to keep it, and when then to delete it? So, question about the life cycle of the battery passport. Do we have somebody who wants to take a swing at that? Don't have one. I can also give a little bit of a response. And so then I will have a swing at it. So in fact, the battery regulation states that the battery passport needs to be linked when a battery is placed on the market again in a second life. So the first life battery passport needs to be linked to the second life battery passport. That is in the battery regulation. And from our reading at this moment, but please be aware that we're still working on that, obviously, and continue to look at the implementation of that the economic operator who puts the battery on the market again, then also has to store the battery passport from the previous economic operator, because it wouldn't make sense for a battery that is not on the market anymore and has been changed significantly by another market participant, that the original manufacturer would keep the battery passport available, right? This battery is in the responsibility of the new economic operator, so this economic operator has to store also the old battery passport. And then that also means that it needs to be deleted once the battery is recycled again in the end. So that's the time to delete it as per the battery regulation, as from our reading. So that's a reply to that question. Then another question also regarding battery passport data, about how often dynamic data should be updated. Maybe we can also take this as a cue for maybe Carolynn and also Franziska about dynamic data in other digital product passports. What's your view on that, or in the pilots of CIRPASS 2? And then we'll come back to the battery passport.
Carolynn, maybe you want to start?
So actually, it's difficult for me to respond because for the moment, dynamic data is, like I said, voluntary data. So things like status of a garment, especially, for example, I'm thinking of a pilot which is working on workwear, high security workwear that is rented. It's a rental fee. So there is dynamic data, but I think that it's very different in this context, which is voluntary, than in the battery, which is mandatory. And I think that here the battery is a very important special case that we all have to understand how to manage.
Yeah, I also see this a bit like that. I mean, in the other upcoming products for now, we don't have this type of issue, but also, as said, I'm not dealing in detail with those products, but this dynamic data, I think, is particularly relevant for the batteries and not so much for other products that are in the pipeline in the moment. So don't have a real link in the moment to other cases. Yeah.
Yeah, but I think that of itself is also a reply of interest for others who are applying DPPs beyond batteries. Thank you for that. And maybe to the battery passport data. So what our state of play is, and that is for our project to speak of, is that it's proportionality that should be considered. So the use case for a dynamic data point is what decides how often you want to report it. And so since there is no clear requirement on the up-to-dateness, because the one requirement that is sometimes cited only that is daily or so, that is only with data that is being provided by the battery management system, not the battery passport. So that should also be clear that there's no mandatory requirement on the up-to-date how often it must be updated in the battery passport, and that it leaves it, as many things for the battery passport, up to the economic operator how often you want to do that. What our suggestion is, there you have good reason why you want to do it in one way, and then it is something that you have to provide as an explanation why you implemented it that way, and then that is at least a sufficient way to go forward from our point of view. But obviously we cannot speak for any regulator or anybody else as a research project. That always to keep in mind. We have a couple of hands up, so I would like to include other people here in this discussion. We need to enable the microphone and camera. I don't see sorry. So we have Fernanda. Don't have a second and last name. So please go ahead if you can. If you want to pose your question to the.
Yes, I'm trying to write because there's a lot of noise where I am at, but I cannot text in the chat. If I could.
We hear you very well. So if you want to pose your question, but maybe not. We also have Lauren Roman.
Okay,
here.
it's okay. If you can hear me, just I wanted to know if will there be expectations around the data immutability or auditability for battery passport information?
Can you maybe rephrase the question? So will there be expectations on the data availability? You mean because of the insecurity about some data aspects, or maybe you can...
Yes, on data immutability.
Immutability.
Okay.
Maybe Jonathan, immutability?
Yeah, can you hear me? Can you hear me?
In the end, just about...
so the auditability for the battery passport information.
Auditability.
About trust mechanisms and how should companies demonstrate that battery passport data hasn't been altered after that submission?
As always, we also, of course, have to make some speculations. In this case, I'm also speculating, right? So in the end, for now, I would say it's about a strict way for you to guarantee that no one else has access to the data. And then you have to make the battery passport's ID unique to some point that is possible to the product passport ID, but only to some extent. Our project is specifically focused on the outcome of your test environment. So what question you have is probably important, but to some extent out of the scope of our test environment, as we primarily focus on the, let's say, things we can test which are outcoming of your own IT system, but what you describe is internally in the data structure. But I think Thomas also has something to mention right there.
Yeah, Thomas, please go ahead.
Yeah, in the standards of the JDC 24, we have at least two responses to that. The one is the standards on the reliability of data. There we define some, let me say, risk levels, how to ensure reliability on the data based on the risk of the data. The second is we leave the responsibility of the data of each passport by the economic operator. So no one else can just change this because this is under the responsibility of the economic operator. So this means nobody else can just change this data as long as this is on the services or the system of the economic operator. So this can happen if you send the data to someone else for, let me say, exchange and so on. But normally the data is on the side of the economic operator. So they have the right to change and they give rights to change. Yeah.
Great. Thank you very much.
Thank you. Then I would ask Lauren Roman also to pose her question, and we will, to end the Q&A, go back to a few more questions from the list. Lauren, please go ahead if you can. Need to unmute yourself, but that should be possible now. As long as we don't hear you, I will go back to the list of questions. So there was one more question about that roles and access management. So we had before in our slides that we have the assumption that we have EIDAs to authenticate roles of different actors. So the question is, what is the understanding of how legitimate interest parties, market surveillance and authorities are identified and authenticated? The EU business wallet is not available and likely won't be in time for the digital battery passport. So how is that going to be planned for the battery passport, but maybe also, sorry about that, maybe in general for the digital product passports? Is the business wallet the solution that will be in the DPPs? Also a general question about it.
I guess that's also a bit aimed at the Commission. So yeah, I mean, the business wallet is currently developed at DG Connect, and indeed it should serve on the long run to identify the businesses and to provide the relevant information. So indeed it is, we are working with them together to find solutions and interoperability with the two systems for sure. In the moment, it's not yet 100% sure how exactly this will be integrated, because as you said, also it's not yet sure when it will be operational. So for now, this is not the case. Regarding the authentication, I did not really understand the question. So it's about the authorities, authentication.
I think it's in general also how any actor will be authenticated as the role that they have or are supposed to have. So who will tell who's a recycler?
This part is still, exactly, this part on the different roles of the actors in the battery passport, I think is still based on an implementing act that is to come. So that's not yet defined. And for the registry, we are working on this in the moment. So we cannot yet provide a final answer how this will exactly work. But clearly the existing systems will be used as much as they can. And yeah, that's actually what I can say in the moment. Yeah.
Yeah. So last question or last amendment also by Jonathan to that aspect. Then we will close the Q&A.
Okay, just to that, maybe also some small addition. Right now, as you already saw, there are some uncertainties about the authentication in general. But in the test environment, we plan also to at least test it in some way where we assume that we have just certain parties who call your own implementation, and those parties will then have certain, let's say, pretended or IDs which represent certain interests. And then we can, of course, test if your own system is actually able to deal with those identifications accordingly. So let's assume we pretend like a recycler is calling your own implementation. Then we have to see if your system is able to provide him the access he actually is required to get, and nothing more, nothing else. So on one point, we cannot do the authentication right now as a step, but we can pretend like a person or a party is authenticated. And then we can test if your system is able to deal with this authentication accordingly or not. So it is not the direct thing you might ask for, but it's still some way to some chance for you to test it accordingly. All right.
Thank you so much, Jonathan. And unfortunately, I know there are a lot of more questions still in the Q&A, but I think even if we had tests 1 hour or 1.5 hours to that, we would still not be finishing up. Please, we will obviously consider those questions in the Q&A session for our work, the continuous work. If you have any further question, also contact us at the project site. Info at the BatteryPass.eu or other participants here about questions that you have to them. So we feel free to reach out to us, and thank you so much. With that, I want to give the last word again to Thomas for the closing of the session. So what are your last words to this audience, Thomas?
Yeah. Thanks a lot to all of you from the project, but especially to Franziska and Carolynn, give us as well, let me say, a broader information. And on the other hand, I'm looking to Manuela. I think we will share the slides from all participants, and we will work on the remaining questions as well, and will let me say provide our input as possible as we can do as much as possible. I think we will not speculate too much on that. And thank you so much, especially to the ones from our projects, for instance, Jonathan and Patrick and our colleagues. And on the other hand, this project is just, let me say, taking into account the pilot, the batteries. There will be a lot of others following. Carolynn is working on all the other pilots, and at least the testing for the pilots at least will take us even broader from the scope of the batteries in the future. So this means pilots are there for learning from mistakes. And you see there are still a lot of gaps, and this is normal because the DPP system is an invention from Europe. So it's our invention from European Commission and our researchers and the system providers. So I think it's normal to have gaps and contradictions. Let's work on that together, and thank you so much for this participation. And I think we will show the next implementations in our next webinar, and will provide our specifications on GitHub as soon as possible, so far I know. So this means it's really important to support you as economic operators, but as well as system providers, to be on a safe side. Thank you so much.